Hello, ladies and gentlemen, and welcome back. We're looking at the 2017 open paper, and we are on our second question. An equilateral triangle has side lengths 4 centimeters. At each vertex, a circle with radius 2 centimeters is drawn. So these circles are going to split the side length of 4 with their radii, and they're just going to meet at the midpoints of each side of the triangle. Okay, the total area of the shaded regions of the three circles is A times pi centimeters squared. Determine A. Okay, so the shaded area that we've got just a little rough picture. The shaded area is the area that's inside the circles, and the centers of the circles are at these vertices. So what we've got here is a whole bunch of what we call sectors, or pie slices of a full circle. Now, how do you figure out the area of a pie slice? Because we've got 3 pie slices here. Well, to figure out the area of a slice, you need to know the radius of the circle. Well, that's good, because we know each radius is 2. And then you need to know the angle of the slice from the center. And so if we were to call that something like theta, the area of the sector is going to be theta over 2, or 1/2 theta, r squared. Okay? You can always double check this formula. Sometimes I forget the by 2, but then I remember, well, a full circle is a sector that goes around by 2 pi. So whatever formula I try and remember, I know that if I plug in 2 pi, I should get the original pi r squared for a circle out. And so if I accidentally forget, and I think it's theta r squared, well, that would get me a circle area of 2 pi r squared, and I know that I'm off, so I always remember to divide by 2. Okay? Just a quick tip for how to remember these sorts of things. Okay? So, alright, so if we know the area for a sector, or if we at least try and remember it, then we're all set. Now, you can do this with radians, which is common, or you could do it with 360 degrees, in which case the area of a sector, if theta is in degrees, is theta out of the full 360 degrees times r squared, times pi r squared. Okay? And that way we view it more as a fraction of the full circle. Well, my mistake. A fraction of the pi r squared, which represents the full circle. So that's another way to do it. Now we've got an equilateral triangle. Depending on how prepared you are for calculus or how well you did in trigonometry, which you might not have even taken by now, you might know that the interior angle of an equilateral triangle is pi by 3 if it's radians, but most people are more familiar with 60 degrees. So you might want to use the degree formula. So we've got 3 sectors. That's the area. So we want 3, and then we just plug 60 degrees into each of the formulas, because they're all 60 degrees. They're all corners of an equilateral triangle. So 360 degrees, pi, and then what's the radius? Well, we said it was 2. So we get 60 over 360, or 1/6. And then 2 squared, I guess we could instead just say 4. Well, that's going to be 12 over 6 times pi, or 2 pi. So what did they want? They wanted A. A is going to be 2. And that's our final answer. We don't write 2 pi down in the box. We want A. A is going to be 2. Okay? And that quite nicely finishes up question A2, where A is equal to 2. All right. So up next will be A3. So I'll see you for that in the next video.